Hi, class. I am at the AICHE, American Society of Chemical Engineers annual conference in Boston this week. So I am recording our Exam 2 review session and get you kind of up to speed, ready to go, and kind of go over all the topics in the exam. So the exam's going to be a little different this time. The last exam was all on paper. This exam is going to be on Canvas. It's going to be a Canvas quiz. And you're going to get a paper exam in case there's a problem, your computer doesn't work, something like that. Then you can fill out the Canvas, you can fill out the paper exam, and I'll grade it and put your score into Canvas. But barring any problems, you won't need to do that. Now, part of the exam is conceptual and the other part is math. And so I do expect you to work out the math problems on your paper exam, and I will give you partial credit that way. And that way, if you miss something, you miss a math question, I can go to your paper exam and you got the right equation, for example, and I can give you half points for that. So, because it's on Canvas, the conceptual questions are going to be fill in the blank, true, false, multiple choice. And that really makes the exam a bit shorter, a bit quicker, I should say. It doesn't make it shorter, it makes the exam quicker. So to kind of make up for that, I've added some questions. So there will be 20 conceptual questions. They will be those three different types. Then there's going to be 9 math questions to go with it. They will be weighted differently to get you the 200 points. So let's just dive right into the conceptual questions. This is really what I want you to know. So these are the things I want you to buckle down and study and understand so that it's the topics that are going to be in the exam. So we're going to be talking about signal measurement. We spent some time talking about quantization and how things work. So you really, that whole lecture on converting analog to digital, you need to spend some time. There's several questions on that. There's going to be pressure measurements. There's going to be a theory question on pressure measurements, so you're going to need to spend some time understanding how those things work. There's going to be several questions on temperature measurements. Remember, we looked at all different kinds of temperature measurements. We looked at thermocouples. We looked at thermometers. We looked at bimetal expansion devices. We looked at RTDs and imaging types of temperature devices. And so what I really focus on understanding all those different devices and when you would use one, when you would use another, what kind of output do you get, how that works. We also talked about position measurement. We did a lecture, so make sure you spend some time understanding them. We've got a question on thermocouple principles. We've got another question on when you would use one type of thermal measurement versus another type of thermal measurement. And if you remember back to the position measurement, we talked about Hall effect sensors, we talked about optical encoders, we talked about rotary potentiometers, so make sure you understand each of those different things and when you use one or when you use another, kind of the theory on how they work. We also spent some time on digital systems. And remember, we talked about all the different pieces. You've got this analog data and it gets converted into binary ones and zeros and all those different things. We talked about 8-bit, we talked about 10-bit, we talked about 12-bit systems. So all those are going to come up several times. We talked about analog to digital. So we spent some time how that conversion takes place. So make sure you do some time on that. Another one of those thermometer things, we talked about anemometers. So you want to make sure you understand how those work. I think I just forgot to mention that earlier. We talked about pressure sensors, and you remember we kind of broke down it's measuring pressure and all the different ways you can measure deflection of a diaphragm. Remember that whole process of how that works, and so that's going to come up several times. Just pressure sensors, how they work. We're going to talk about pressure sensors, kind of some applications for pressure sensors. We're going to be back to more temperature measuring. So I think, did I mention thermistors? I think thermistors are going to be on here. That's another, we talked about a lot of different sensing systems. And you're kind of find that's a theme that we're going to see several times in here. What is this measurement? What is this system? What does this sensor do? How does it function? And when would you use one type of sensor versus another type of sensor for an application? So that's just going to come up over and over again. RTD, we've talked about that. We've also talked about strain gauges, and don't forget, when it comes to strain gauges, how do you convert resistance measurements into voltage measurements, and why is that important? How you do that? What's the process? The math that goes into that's going to come up again. What else? Optical encoders, I think we've got a question there. We've got things about logic. We talked briefly about programming and how all those different type of gates and all that. So make sure you spend some time there. I know we briefly talked about semiconductor electronics and that kind of stuff. So you need to spend some time and just review that. There'll be a question on that. Flow sensor output. So yeah, a lot of stuff on the conceptual. So 20 questions on the conceptual. And if we roll into the math, here we are in the resistance calculation. So temperature resistance calculation is a couple questions on that. How do you calculate temperature? Wheatstone bridges, DAC voltage. Remember we talked about data acquisition, and so there'll be some questions on that. And really that comes back to that whole 8-bit, 10-bit, 12-bit, and what are resolution and all that. So that's on here. How to calculate thermocouple temperature measurements, measuring temperature with thermocouples, paddle wheel flow measurements, and linear potentiometer position. So that is the exam. That's what I really want you to study. Those are the important things that we learned this semester. So formula sheets, once again, for all the formulas you can create those 8.5 by 11. You do front, you can do back. It's a formula sheet, not a word sheet. So that is important. I think that is it for the review session. We kind of went over what's different about the exam this time. It's on Canvas as a quiz. You also have a paper exam. Do the math questions on the paper exam, and you'll get partial credit that way. I will still be traveling on Wednesday of the exam, so Naveed will be proctoring the exam for me on Wednesday, and then I'll try to get it graded and return all your scores on the following Monday. If you have questions, you can feel free to email me, and I'll try to reply within 24 hours is kind of the normal thing. I will create a discussion on Canvas. So if you ask a question there, it will send me a message that you've asked a question. And that way the question will be available to everybody else, and the rest of the class can see your question and see my reply. And as you have questions about the exam and about studying, that's also a good place to look and see anything that you might have missed in this discussion. So I wish you the best of luck. You're going to do great. Feel free to put a message in the discussion section on Canvas, and I will reply to you. Good luck, and we'll see you next week.